What's up, guys? Welcome back to Cool Fred's Garage. So today we're gonna play around with the electric fan control box. I'm gonna talk about that a little bit and why we chose this particular box. So I got the box in and got it hooked up. I had an issue with the sensor because the fans were kind of running when you first turn it on. So the fans are not supposed to come on right away unless you trigger the fail-safe or you turn it on the AC. So I'm gonna show you guys what we got going on. So on this 1978 Malibu Classic project, got several videos on it while I'm working on it. Basically did an engine swap, trying to get this thing up and running. So I'm gonna show you guys a little bit about the car. So we almost got this thing ready to fire up. Just got a few little loose ends to tie up on it. The few little things I got to do is basically I got to get that lower radiator hose down there attached, and I got to put the upper radiator hose in and get the coolant in it. And then after that, the most final thing I need to do is to get the we got a tachometer for it. That's right here. So I got to get that installed and mounted, and this thing will be ready to fire up. So if you guys been following this series, there's several videos of me basically pulling out the old engine, getting this this built engine in here. So this is a 350 roller motor. It's got a roller cam in there, and it's got some Summit aluminum cylinder heads on there and stuff like that. So it's got a lot of little goodies. It's got a CVF belt drive kit. So I got a lot of videos of me talking about key stages of putting this thing together. But today we're focusing on the this fan control box here, which is from the Auto Cool guy. So this is the HF 125. So I've got experience running a few of these boxes. This will be the third one that I've installed, and I've also recommended a fourth one to someone else to install. So I know of successful installs with these boxes, but you know, every now and again you may run into a little issue with something or a problem. But I don't have a problem necessarily with the box itself. Today I got a problem with the temp sensor input. So pretty much what was happening when I was testing out this box is the fan, like I would turn on the car, the ignition on, and the fans would just run. Alright, so pretty much what happened is when I ran into that issue with the fan staying on, I started doing a little troubleshooting and checking all my inputs. I knew my fail-safe was working, and the AC input, when I switch on the AC, like it turns the compressor on, it also sends a signal over to the box. So all of that was working, and then I unplugged the sensor, which is right here, and it stopped. So so pretty much just kind of reading through the instructions. So one way you can test the box is you can kind of you can jump the sensor wires at the control box, and it's supposed to go full RPM. But this thing has got some real good instructions on how to wire it up and everything like that. It's actually pretty simple. The thing about this box here, now this is the HF 125. That stands for high frequency. So this one is capable of running brushless fans. So I guess I'll talk a little bit about how I got into running these style boxes a little later in the video. But so that's important because you need certain type control boxes to control brushless fans. But these fans right here are not brushless. These have brushes in them. So these are conventional, like a brush motor, dual 12-inch small fans. So those are some real high output fans. I think they put out around like 24 to 2500 CFM, something like that. I think they're like almost 1300 CFM a piece. So both of them together, probably at max output, can probably put out about 2600 CFM, something like that. But so I mean, they're not, you know, like I said, they're not brushless. So, but in case the customer wants to upgrade to that in the future, this box will handle it. So this is the same box that I have on my car. It's been revised a little bit because the one I got on my car, it's like the knob goes down and all the readings and stuff are different. But this one has been revised a little bit. So let me see here. So they come with real good instructions. And basically, so what I'm gonna talk about is the sensor right there. So, because I'm about to measure the resistance on the sensor, on this new sensor, and see what we got. Because when you put it when you install it in the car, so basically what it does, this is the operator hose, but I'm using it as an example. So you basically kind of place this on the radiator outlet, and you kind of just slip the hose over it. But you need to make sure that it's not touching like anything else that can kind of ground out the sensor area there. So that can cause a what you call a erroneous or a false input. All right, right now, so I'm checking the resistance on the sensor, and I got like what looks like 63,000 ohms. Now it is a little bit chilly, but on this paper it says that at room temperature that it should read 40 to 50,000 ohms. So I'm thinking maybe because it's a little cooler, it's reading a little higher. So it's probably like 60 something degrees. Typically room temperature is somewhere I guess around like 75 or 78 degrees is what they would consider room temperature to be. But I do consider that a good reading compared to the reading that I was getting on the other one, because the other one was going out of OL, which is pretty much out of range, or it's basically no continuity. So wasn't getting no continuity. So basically, you got all your paperwork here that kind of outlines everything, and you got some of the like your wiring, your sensor wiring and stuff like that. So I'm just gonna talk about the box a little bit. So this particular box right here is unique, is because it controls the ground side of the fan. So you basically come in with a chassis ground, and the ground output that goes out over to the fans, which I got on those Delphi style connectors. So I got some weather pack connectors. So I take the factory connectors off of the fan and put I got two pin weather pack connector on there. So the reason I do that is for serviceability. Like if somebody, if the customer needs to take the radiator and the fans out, basically you just disconnect those two plugs and you just pull the whole thing out of the car after you get your hoses and stuff. So that's something I've been doing to my cars, and every time I do an install like this, I pretty much do the same thing, or I highly recommend it because it's just easy to do. So basically, so I got the ground side. So I got and it tells you right here. So those are both of the fan outputs. Now it has one terminal, but you can tie two fans there and control those fans. Then you got chassis ground, which is over here. Then you got one ground to power at the box. So this right here is the input side here. That's the output side down there. And you got a battery. You got a 12 volt hot at all times, which goes there. You got ignition hot, which is when you turn the switch on. Then you got ground. So I just got that grounded over here to the chassis. So on your control box, and the sensor goes right here where these two are. Where it says sensor. Don't matter how you hook it up. So right there. And then this right here is the AC input. So when you trigger the AC, when you turn the AC on, that right there will turn the fans on. It'll basically override the box a little bit to turn the fans on. And this last one here, which is the fail safe, it's like you're in a situation where, if something was going on with your sensor, or just anything, you have an issue, you think the temperatures are kind of creeping up on you, like if you're out in Texas in that desert heat, you can flip the switch and it'll put the fans at 100%. Now, as far as over here, I got these fans. Basically, this blue wire here, that's pretty much straight hot power from the battery going to the fan. So the fans get pretty much juice straight from the battery. So I got that wired into a 10 gauge wire, which is more than enough for these fans. But they both have their own 10 gauge supply of power. So now these right here is the fuses. These right here are some universal Delphi fuse holders, and we got 40 amp fuses in there. So both of these, each fan has its own fuse, and it's in this nice little connector there. So if you have a problem, like, you know, one of the fans not working, you can easily come here. I haven't had any of those type of problems, but you know, if you do have a problem, you know, you can get right there and check your fuses. And of course the sensor is right here and goes over there. So that's what I'm about to do today, is install that sensor, and then we'll get the box powered up and just show you guys briefly how it works. Alright, so a little bit about how I came about running these type of boxes from the Auto Cool guy. So I started off with the ENB100, which stands for no buzz, on my Chevy, and I had similar fans to these in there, but then I did later upgrade to some brushless fans and had to go to the HF125. But pretty much back in 2018, I had took my engine out, rebuilt it, and I got some electric fans to go on there and things like that. Just trying to spruce some things up, paint the engine, and do a few things to the 400 small block in my 73 Chevy. But I wanted to go electric fans, and I was initially looking at the Durrell controller and a lot of other controllers, like from Summit Jegs and stuff like that. And I was just doing a lot of research, and they just didn't have good reviews. So I kept researching and I came across the Auto Cool guy, and I started looking at some of his videos and stuff like that, and I thought it was pretty impressive. I think, you know, I'm gonna give that a shot. So and the one thing, his control box compared to a lot of those other aftermarket ones. Now this is back in 2018, so now this is 2024. So now technology could have came a long way. I've seen some other boxes come on the market that may be, you know, it's a lot more newer stuff out there now. So it's a lot more control boxes out there now. So it's some things out there that may be comparable or decent now. But back then, everything had bad reviews. But like I was saying, what I was about to say is what separate his box away from a lot of ones that's on the market is a lot of the ones that were on the market, it was trying to control the power side of the fans. So this box right here uses a technology called PWM, pulse width modulation, which is found on a lot of modern cars today, but it used to be big on BMW and Mercedes. So basically where they use the ground side, and they kind of, like if anybody's into scoping things, it's like a square wave signal. So basically they can change the duty cycle and vary the, they usually measure it in hertz or whatever, but they can kind of change it like that. So this box is capable of doing that, and it controls the ground side. So it basically it's kind of like a small power that's kind of slowly cycling the fans on and off, but in a certain varying wave pattern that, you know, you can make the fans run at a slower speed to a higher speed. So that's probably another thing I didn't mention, that, you know, this is a variable speed control box. So instead of just a high-low, it's variable speed. So I want to say that it can run the fans from as low as 40% all the way to 100%. But the other good thing about it, it kind of, instead of like if you hit the fail safe, it's pretty much instant on high, wide open. So basically, you know, when you first fire up the car, versus it having to go full on. That causes a big surge. You know, basically it pulls a big draw from your battery in the alternator all at once. So what this box is capable of doing was called like soft start. So it'll kind of slowly turn your fans on and it'll slowly bring them up. Not like slowly, it does it like at a certain rate, but it'll gradually bring them up to operating temperature. Kind of like how the blower motor works in a lot of like luxury cars. Like, you know, a lot of BMW, Mercedes, when you turn the blower motor on, even in some of the Cadillacs, when you turn on the blower motor for your AC, if if you turn it on high, it'll kind of just gradually, slowly kick up there. But if you got like a Honda or a Toyota or just something, you know, time you click that dial to 3 or 4, you know, it's just gonna go wide open. So basically, it's just more of that kind of soft start technology, gradually bringing them up to speed, just to kind of keep some of that surge off the alternator. But I mean, I thought the variable speed was cool because, like, the variable speed means that you don't have to, like, if you really don't need, because theoretically, when you get to rolling down the road and you got air coming through the radiator and the grill, and this is a high performance radiator, so it should cool real good. So a lot of the fixtures, if you're doing 30-40 miles an hour down the road, like the fans, you know, once that temperature is realized at the radiator, I think that's the outlet. The fans should turn down, but when you're in traffic and the temperature starts to creep up, it's going to increase the speed of the fan. So to me, I think it's a very efficient way of working, and to me, it also works. So that's what I kind of like about it. Now, another thing on this box right here that it does, see, a lot of the other system I would research, it would use a sensor. Now this right here is for our temp gauge inside the car. It's for the water gauge, but a lot of them would want to use basically a sensor to see what the coolant is coming out of the engine, this is the hottest point here. So, and usually that will be set from like 180 to 195, and it's using that to operate your fans. But this one right here uses the cold side of the radiator. So basically, after all the hot coolant has come in here and cooled down, but basically even before it gets hot, it's seeing how hot that's getting. So in this case, by the time it gets there, it'd probably be like the coolant would probably be around 120 to 140 degrees or something like that. So I think somewhere around like 125 and 130, it starts to kind of kick on. So basically, this system is kind of monitoring how cool the radiator is. So, and basically, like of that value over there, the rule of thumb is they say they want you to take a temp gauge. You kind of can measure here and measure there, and it should be a 20-degree difference. But a lot of times, like, you can get these things, like, they'll keep your temperature between 170, 180 degrees, or pretty much wherever you kind of want it. And you got the capacity or the freedom to kind of turn this thing to make the fan speed faster and slower at a certain temperature. So that's cool too. So I'm gonna go ahead and get that sensor installed and get this one out of there, and try to get this thing connected, and then we'll test it out. I've got the new sensor installed, and I'm just checking the resistance on it before I hook it up to the box. So I do got resistance on it. So the way this sensor works, the lower the resistance value goes down within a certain range, it starts to turn the fans on. And once it gets closer to zero ohms, then it'll power the fans at 100%. So this is how I got it installed. It kind of is down there, a little tricky to see because I got this heat protector on it, but it just fits under your lower radiator hose, and then I just got it running along down the fan assembly there, up into here. So I'm about to connect that, but before I connect it, before I connect the sensor, I'm actually hook the battery up and kind of show you guys a little bit of a rundown of how the box works. All right, so here we go. So just a little bit of I guess a rundown of the box. But basically, if you got everything connected, I don't have the sensor connected right now, but if you got everything connected correctly, when you turn the switch on, you just saw the fans do like a little test spin. They're gonna kind of do like a quick test spin for 1 second. Another thing I wanted to point out, so this right here, this is the hot at all times fuse here, which I got in this fuse holder here. So this right here is a 3-amp fuse. My camera's not really zooming in on it like that, so it's a little tricky to see. But it's a purple 3-amp fuse. So pretty much this thing, to turn on the box, it don't take a lot of power. And basically, if something shorts out, this would just kind of keep from like causing this wire to burn or get hot and things like that. So the instructions, they recommend like a 1 to a 2 amp. Like right here, they show a 1 amp fuse on the battery hot, but the lowest I had was a 3. So I've been running 3 amp fuses on all my installs of this right here. So another thing, we basically know we got power to the box. We got our ignition and everything, because like I said, once you turn the key, it's gonna do a test spin. So I'm gonna hook the sensor up shortly just to make sure that it's working properly. But I just wanted to show you guys, if you ground these 2 terminals for the sensor, that's another way to test the box to see if it's working. So if you short these to ground, the fan should power on at 100%. All right, I just had to find my jumper wire. So this right here is my jumper wire. So I'm just gonna kind of touch it on these 2 wires here, on these 2 terminals for the sensor. And you can kind of see the fans come on. All right, so another thing I'm gonna do is I got my fail-safe right here. So this is that fail-safe switch. So basically all it is, it's just a switch. One side of it is going to the box, and the other side is just going to like a ground under the dash. So basically this kind of does the same thing that we just did with the sensor, but it overrides everything. And it turns those fans on at 100%. And the other thing is our AC input. Once I turn the AC input on, you can hear the fans come on. So they generally come on to a certain thing. I got to see where the box is set, because I should be able to adjust that from 0 to 100%. But it looks like they're just slowly kicking up. All right, so another thing, we just checked the AC input, but another thing I wanted to kind of show is there is a plug on the bottom of that box. I got my mirror right there, and you see that dial right there? So that's how you can adjust the input for the AC. So I got that turned all the way, I want to say to maybe 100% or whatever. So it basically, when you turn the AC on, it powers the fans on, and a combination of that input and whatever the temperature is, it kind of, I want to say that the temperature of the engine overrides the AC. But in a case like, let's say you just turn this thing on, let's say it's cold and you start the car up, but let's say it's like the engine's cold, but it's in the summer, so it's kind of warm day in the summertime, but the engine's cold, you're just getting it started up. So as soon as you turn on the AC, it's gonna power the fans on, and then depending on what the temperature is, it'll adjust accordingly. So I got that turned to the max setting. So I just make sure that was working properly. So there's a plug that sits down in there, which is this plug right here that covers that up. But that is adjustable. That's another feature. You can adjust the AC input on this thing. All right, so now I got the sensor inputs hooked up right here, and I kind of got it going around the box. So I kind of put a little bit of some insulating tape here on the around the edge, just so you know. But this outer edge is pretty smooth, so I don't have to worry about that chafing the wire or anything like that. But you know, I just put a little bit of insulating tape around there just in case. But so now, when I turn the ignition switch on, it does the test spin. I think it, let me see here. Okay, I was trying to figure out why it didn't do the test spin, but it didn't do the test spin because it's still, the box is still on. So another cool thing about this box is when you turn the ignition off for about 60 seconds, the box is active. So that's good for turbocharged applications, or basically, so it keeps the fans running for up to a minute when you turn them off, and then it should go out. But after the box is powered down, I would pretty much know that it's powered down, because if I flip my failsafe, it won't have any more power. Like right now, the failsafe is flipped. So now I'm gonna recheck to see if it does the test spin with everything hooked up, the sensor and everything like it's supposed to. And there we go. So it did the test spin. So so the box is ready to roll. So basically, once we get this thing running, as the temperature creeps up, the box is gonna slowly kick on. So that's gonna be it for right now for this video. But once I do get it fired up and everything, you just heard that clicking noise, so the box just turned off just then as I was talking. But once I get this thing up and running, I'll kind of I can't really let it run for a long time, because this thing's got no exhaust. It's got headers on it, and the exhaust needs to be hooked up by the exhaust shop. But I will try to get a little bit of footage if I can let it warm up just a little bit, enough to kick those things on to let you guys see how they come on. So, but that's pretty much it for right now. Thank you guys for checking out Cool Fred's Garage. We'll see you on the next video.